I'm supposed to talk about Agile Software Development, an overview. I often do this as a day-long class. So forgive me if I talk a lot, or I actually try to trim it down to 30 minutes. Hopefully I'll be successful with doing that. So it kind of touches as well on modern management techniques, Agile Software Development. Just to get a background on the audience, anyone here already doing Agile Software Development or are already adopted Agile Software Development? No one? Okay. Yeah, I know you guys. I work for you. Okay, so to start, hope you don't get dizzy with my presentation. Okay, so this is me. This is the only decent picture that I have. Parang natutulog lang, di ba? So right now, I manage 80 plus software architects, engineers, PMs as vice president for consulting services. In short, I am overhead. Sorry, boss. I'm just kidding. I also train and coach our clients. I used to coach teams when I was working for Sabre, who are located in Poland, in the UK, in Australia, in the US. So, and as of late, I've been training a lot of IT professionals as well. Mostly they are clients of Orange and Bronze. And yeah, as Kat mentioned, I've been an open source contributor for the longest time, none of which are very famous. Okay, so let's begin. Before I actually talked about Agile Software Development, let's talk about what it is not. Okay, just to compare. And why would we even consider doing Agile Software Development? Why was Agile Software Development started anyway? So I begin with scientific management and heavyweight processes. I'll tell you a story about this guy named Dr. Winston Royce. Anyone knows Dr. Winston Royce? I think I saw him in Mega Mall. Just kidding. This is 4 decades ago. 1972, I think, or 1970, somewhere in the 70s. He is a software engineer and a PhD at the same time. He wrote, during that time, there was no prevailing software development standard. He was in a situation where he needs to do a large-scale software development project. And then there was no standard, so he actually wrote a paper called Managing the Development of Large Software Systems. Okay, so he is a PhD, he is a software engineer, and he is faced with managing a large software project. Now, in his paper, what he did was to have a straw man, meaning a process that looks at its surface ideal, perfect, and like if any executive looks at it, it's fine. But then slowly deconstructs it and seeing that it's really not really effective. Eventually, he shows what his proposed process was. So a straw man, it's really good, it's really looking good, but then it's really not that good. And then, actually, this is what I want. Now, he submitted this paper to the IEEE, and then it was archived there and sitting there. During this time as well, the US military was starting a large software development project as well. And then again, there's no standard. So they went to IEEE and saw, look, written by a PhD, it's about large software development projects. Let's use this. The unfortunate thing about this is that they only read up to the second page. What was in the second page? It was the straw man, right? I don't know, for some reason, the Department of Defense Standard 2167 became the straw man that poor Winston Royce wrote about. know what the straw man was? This is the illustration. Does this look familiar? This is from the paper itself. I cut it. Anyone recognizes this? It's waterfall, right? And the funny thing is, right below that, it said, he wrote, I believe in this concept, but the implementation described above is risky and invite failure. Why that happened, I have no idea. Okay? Actually, Winston Royce never defined, never coined the term waterfall. It's the people who was using it. But then again, it became the standard of the military and caught on. So, this is what you have, waterfall. Of course, there was this modified waterfall process that was actually what the proposal of Winston Royce was. But this is what became the standard. Okay. So what are the problems that you will see in such systems? Oh, sorry. Winston Royce, all his life, is a man who is against waterfall. So he is the father of waterfall, but he's saying that don't do waterfall. Okay. Okay, that's a history for you. Okay, enough with the with software development, we are so used to thinking that we are dealing with predictable and repetitive work. It's like bricklaying, wherein I could predict if I have a bricklayer that could lay 50 bricks in half an hour. Then in 1 hour, you will be able to lay 100 bricks. If I have a person who's laying bricks, who could lay 100 bricks in 30 minutes and have both person work together, then we will have 150 in 30 minutes. So it's the same with manufacturing, wherein my processing plant will produce so and so amount of cars at this amount of time. If I add new machines, I could predict that it will produce even more. Okay, this is traditional way of thinking with regard to how we do things. So it's just normal that maybe software development is kind of like this. Okay, I don't want to look at the picture anymore. Okay, it's like ordering pizza, wherein I would like to have this pizza with so-and-so components, meaning I could add pepperoni, I could remove cheese, just like that. So it's an oversimplified way of looking at it, but this is sometimes how we treat software development. It's predictable, repetitive. It's like ordering pizza, wherein I could customize it the way I want, and I will be able to get it at the time that I want it. What's the problem here? It's all assumptions. I don't know if you'll be able to wait. Does this work? Hello. Okay, so this is how it's usually done. In a project, we start off with a lot of assumptions. Okay? Without delivered work, nothing to verify with, it's all assumptions. And then as you deliver work, some work being verified, you slowly trim down those assumptions, right? At what point in time do we set budgets? Do we set contracts? Somewhere here. So we actually made handshakes. We signed contracts at the point where we have no idea. Okay. We are faced, so software development, we are faced with problems that we don't know and is continuously changing. We are providing solutions that we don't know that is continuously changing, and we are combining a set of tools that we have no idea what the result will be and is consistently changing. This is how software development is. Now, we have a lot of assumptions. We assume that whatever requirements that we gather, or rather, whatever requirements we write down, will provide the business value of what our software is supposed to do, or to give. We have this big assumption that we can create a perfect architecture and the design of the system up front, wherein I could detail it to the point where I could just feed it to the computer and it will produce the software. Okay? And we assume that people are replaceable cogs, wherein if I put a senior level 3 in place of another senior level 3, it will perform the same. We assume that the chemistry is not going to change, that the skills, the abilities, and the knowledge are all replaceable. Okay? We do function point analysis, we have human resources, okay, hire so-and-so and so, here's the checklist, and then if you plug it there, we have a predictable project. Okay? Those are big assumptions, and these are big design up front. Okay? Are you still with me? Okay? So big assumptions. We do our contracts here, we set our budgets there, and then see you at the end of it. Okay, let me tell you a story about, it's a good metaphor. While I was driving last night, I want to inject it here. I don't know if this is going to cost some time. But, for example, you are the customer. This is Quezon City. And here's some point in Quezon City. You are somewhere in Batangas. I mean, the team, you will have to deliver some, your project is to deliver, can you guys see what I'm writing? Okay. So, you have a package to be delivered to Quezon City. Okay? Now, this place here is not in any type of map because it's still under development, something like that. So, you do an upfront requirements gathering. You got a satellite image of this spot. So, okay, we kind of see that there's a big road here. And then from there you could just connect it. This is probably Alabang or going to Quezon City. Okay, so this is unknown, but we have some high-level view of what it is. Satellite data. Now you commission. You have a bidding process. Okay, who could give me? I have a deadline that this should be here by in 5 days. That's too long. In 1 day, with 1 fuel of tank. 1 fuel, 1 full liter of fuel. 1 full fuel tank. Sorry. Full fuel tank. So let's say that's 48 liters. So you have a bidding process. We will use a Navara because it's rough road here. That costs a lot. We will use Expedition. The fuel tank will not. And then the guy who wins lowballed it. We will use a Kia Pride. Okay? I think with how we see it, it's a big road, yet, and from here on we already can determine it. So you have a fixed time and you have fixed resources. Now, they have a handshake. Okay, you meet me here. I'll see you in 1 day. Now the team starts moving. When they got to this point, it's rough roads. Okay, let's try it out. Our Kia Pride should be able to cross that. Okay, so at this point, they had a flat tire because they tried forcing it. Okay, so we lost like 2 hours of our time already, of our one day. Okay, so they tried speeding up, even if it's a rough road. And then there's NPA here. Okay, so they can't cross because they'll be hostage or something like that. They have to go around it, and they have no idea where they're going. And eventually they got back here. So fuel is already low. Time, you're going down as well. Now, you got back there, and then your fuel, you want to fill up because you might not be able to reach this anymore. So there's a gas station here. You fill up, you use your own money because I just need to reach my my deadline and with that resources. Then you go to the expressway, since you already lack the time to meet the target. You speed up. You go 150 kilometers per hour in South Expressway. So you break rules. Then you get ticketed. So there's more cost. You pay for ticket and things like that. Now, since you already are like 1 hour, you have 1 hour left. You don't stop at red lights anymore. You just zoom in because I'm not gonna reach my target anymore. Okay? So, and then, biglang may bumangga sa inyo. So, more cost. And probably, you were able to barely reach it on time. So, what are the metaphors here? This is like what we have. We have a big assumption. We try to review that if all the details are there. And then, when you go down to the level of when you're actually executing, all these problems are not, you can never really predict all these things. Okay, so this is a good metaphor for software development. Okay, so I will get back to this later to show you how Agile would have tackled this. Okay, so it's a defined you have a defined process. You have a process wherein you think that everything and all conditions are already satisfied, right? That's just obey the process and then we'll get a successful project. So you have this, a rigid structure wherein you could plug in whatever that fits there. Now, it's software. It's meant to be soft, meaning it's meant to be easily changeable. Okay? There's something weird already when you have very rigid processes there, like change requests. Whoever had a really smooth change request? It's software. You have to be able to change it easily. Anyone here who have a Gantt chart that is accurate, like even projecting long term? So why are we even using Gantt charts? Gantt charts, you start doing them with critical paths here and blah blah and blah blah. Once you start executing, there's a fog of war wherein you will never recognize this anymore. Okay, but still the process says, let's do Gantt charts. Now the process shows you that there are things of problem, we could see them. But actually the process hides more than what it shows. Because you have, It's the people who are not even involved in the context where development happens, who are making decisions. They can't see what's happening down there. That's why what they know, they just show. But then again, we're hiding a lot of stuff with regard to software development. Okay, I think I have to speed up my presentation. So that's the process. And then there's that communication thing that's happening with standard traditional way of doing software development. You have phased communication, wherein you do requirements gathering first, and then you do business. Okay, this is business doing requirements, and then your technical requirements, and then actual development, and then testing. The communication happens in phases. Once we're done here, we can go to Boracay. And then these guys could start working on it. If there are questions, they're in Boracay, so let's just assume. And then we give it to the next people. You do development, and then how could I talk to these guys? Okay? And so on and so on. The problem is, too much documentation have this false impression of completeness. Hindi na tayo mag-uusap kung ganyan nakakapal yung documentation. Why would we even talk? It's all there. Right? But the problem is, the more documentation, the more you won't read it. Okay? And then words can be very imprecise. What does this mean? Your meal comes with soup or salad and dessert. Does this mean your meal comes with soup or salad and dessert? Or your meal comes with soup or salad and dessert? So people will think that it's complete, but it's really these little things that could cost you millions. And then there's that feedback. You don't know whether you're doing it correctly because you wait for your face, and then that's the only time I get feedback. Okay, so what's the problem here? That's how the customer explained it. That's how the project leader understood it, and so on and so on and so on. They are not communicating properly. We wait for the requirements, and then we do it. And then we wait for the software, and then we test it. How we understood it in our group. So it's like a relay race. You know, in a relay race, like Gantt charts, these people wait around until someone passes them the baton. Then these people wait around until someone passes them the baton. What if this guy misinterprets the direction and goes there? Never really meets this guy. Now the project's doomed. Or this guy took a longer time reaching there, and then everyone is delayed. Okay? This is how we do it in waterfall. And since they all have their own artifacts, they will have different goals. The business will go. The business group's goal is to produce requirements. The software development team's goal is to create software out of those requirements. The tester's goal is to make it a hard life for the developers. Okay, so it's like that. So what does the software developers see? This is an SRS, a valid SRS. The product shall have a gas engine. The product shall have 4 wheels. The product shall have rubber tires each wheel. The product shall have a steel body. Imagine that. You're building something like this. Now, there are no tires available. What do? You make decisions, but that's what the requirement says. So, okay, I'll wait around and until a real rubber tire comes around. And then again, the business writes it this way. In order to have a balance, in order to have good balance while mowing my lawn, as a homeowner, I want the product to have 4 wheels. Okay? So what were you envisioning, just given software requirement specs, compared to knowing what the value of the requirements are? You can't prioritize because you just do it one by one, module by module, and your target is just to check that off the list. Okay? Instead of you guys knowing about what the business value is of each requirement, and then that's the time when you can make informed decisions. Okay, there are no tires, but it's a lawnmower, so maybe we could use some other alternatives. Okay, and then we could still have a release of the project. Different goals. Now let's go to Agile Software Development. Okay, as Calen mentioned already, there were already people who are doing alternative processes because they saw all these problems with the way we're doing it previously. So guys like Ken Schwaber and Dr. Jeff Sutherland, they created Scrum. Kent Beck, XP, Alistair Coburn for Crystal, and yada yada. All these guys got together and they came up with the Agile Manifesto. Now, they have practices. What are the intersection of all our practices? It's our value system. When you say you value something over something, it influences how you decide. For example, I value my family more than my job. Now, I have to do overtime work, but it's my daughter's birthday today. So, I will decide towards something that I value more, which is screw overtime. I'll go to my daughter's birthday. So, it's the same thing with how you make decisions. And this is how their practices were concepted. Individuals and interactions over processes and tools. Meaning, if your processes and tools gets in the way of individuals and interactions, get rid of it. What I want is high bandwidth conversations, people talking face to face, and if my processes like protocols that you have to go through this before you go through that, that's going to result in failure. Not to say that these are not important, okay? They should, the processes and tools should facilitate the individuals and interactions. When we talk, we want to look at working software rather than looking at documentation. Documentation is cool, okay? We know there's a business need for that. But we want the working software first. I know of a project, 6 months long of documentation, and then there's no working software. So they invested a lot, and what they got was a library of documentation that no one will read. Customer collaboration over contract negotiation. If we have to, it's important to have contracts. It provides security for both parties. But don't let the contract get in the way of us actually collaborating on what we want. On what we want done. Okay? And then responding to change over following a plan. Plan is good. We always must have plans. But plan just enough because they will change. So, your Gantt charts, throw them away. We just want, or don't throw them away, but have an open mind that it will change. Okay? So, that's the value system. And then there are principles. So, there are 12 of them. You can just browse through agilemanifesto.org. So, it says here that you can do you have to have continuous attention to technical excellence, do some reflections. So it's highly inspired by the Toyota production system as well, where they have Kaizen or continuous improvement. So it's a three-legged stool. You have the values, you have the principles, and then the practices. Okay. Now, let's juxtapose with what I said a while ago, with what I was talking a while ago. So, predictable and repetitive work. If it's predictable and repetitive work, when you do your software, when you need software development, why don't you just get it off the shelf? Because it's already there. I mean, someone already have done it. Is it always this way? Why do you want software done? Because it's always something new. Otherwise, just get something off the shelf. So, a more appropriate analogy is that it's like an R&D project. It's a new product development. It's always something new. Okay? It's like, instead of ordering pizza, it's like having a painter, commissioning a painter to paint your idea. Okay, that you have no idea what to expect. So instead, so we still have a lot of assumptions. We still have a lot of assumptions. But with assumptions, we verify that with feedback. Here's the thing. Business people don't know what they want until they see it. They know how to solve problems, or rather, they know the business value they want out of the software, but how it will do it, they wouldn't know until they see it. They could assume. The same way that development teams don't know how to do it until they've actually done it. So what you do is the Deming Cycle. You plan, lightweight plan, we do it, we check whether it's doing what we assumed, and then we act, meaning we improve on it, and then proceed again to planning. So it's an iterative process of collecting empirical data, which is not in the slide. Okay. So big design up front, it's okay to have a plan, a design. Okay, but plan just enough. In again, quoting Toyota production system or lean production systems, inventory is bad. Okay, anyone here who knows Toyota production system? Yeah. Okay. Yeah. So inventory is bad. Zero inventory is the goal. All your design, all your assumptions, all your documentation, they're inventory. Okay? The less of that and more actual, verifiable things that you have, the better. So you work in iterations and in increments. You have a big vision, slowly going to the details with your design. So let me go back to the car example. So instead of having, we have a target day, you have budgeted resources. Now instead of them saying that this is where I want it at this point in time. Instead, okay, this is what we envision where it will be in one day with one tank, with one full tank. Instead, the one who wants his package delivered rides with the guy in the car, and then they do the plan, do, check, act cycle. So we plan to go here. So are we proceeding to plan? No, we have to slow down. So let's set the expectation. We might not be able to reach this because this is gonna slow us down. Instead of projected 80 kilometers per hour, we're just going 60 kilometers per hour. So we assume that early at this point, we could assume that we might be only able to reach this point. So you coordinate with the person here. That's fine. I'll meet you there. Okay, and then you go here. You go around. We have low fuel already because we went around. What do you do? Okay, probably go a little nearer again. So you can make decisions as you have empirical data available. You have someone who does not leave them from business. We make decisions as we get more knowledge. In a paper by Hirotaka Takeuchi and Ikuhiro Nonaka, actually Scrum was based on largely based on this paper from the Harvard Business Review. It's in 1986. It's about teams that are cross-functional. During this time, I forgot the names of the companies. I think it's Xerox, Fujitsu, or something like that. And they are hardware companies. What they saw was that the best way to actually create new products or R&D products is to have a cross-functional team that is self-organizing. So modern management techniques is here. Meaning the people in the right context fix the problem, not someone else outside of the group. So what you want is more knowledge ASAP. So what you want is, so if this is the amount of knowledge, if you have this kind of phasing, like I will only acquire knowledge after that phase, you won't win the game if someone comes in and have this kind of chart. It's a knowledge game for solving unknowns. Okay, and how do you accomplish that? You are cross-functional, meaning everyone is from different facets of the business, software development, and testing are there. You gain the knowledge all at the same time, and with different points of view. You have empirical process controls. Now let me tell you about the Battle of Trafalgar. This is the 1800s. Vice Admiral Horatio Nelson won the battle. This is a British naval fleet, and then they were against France and Spain. They won without doing the standard way of doing battle during that time. They went unconventional on them. This is where the notion commander's intent was born. Wherein what he told his troops that, okay, we have this plan, but I know that this won't really happen. So my commander's intent is for you to have always have an enemy beside you, meaning the boats. They will always have enemies beside you. And they won, because when you go into war, you can predict all you want in the war room, but come down the trenches, it's free for all, whatever happens, come what may. Okay? Just keep one goal in mind, do whatever it takes. So it's the same way with self-organizing teams, wherein the manager doesn't make decisions for them. It's really the team who are in the trenches, who knows about their problems, and who could potentially fix their problems for them. In Toyota, they have Genshi Genbutsu, wherein the managers can actually go see and are capable enough, or even better, to do the work of whoever is down there. So it's the modern management technique. Okay, so I've already talked about cross-functional teams. So unlike relay races, it's like rugby, wherein your QA, your developer, your business, and whoever part of the process of software development are together, not in phases. So they want the ball in the other end of the field, and they do it as one team instead of handing it out. And they have one goal, which is to deliver things of value, not to test, not to write a lot of documentation. No, everyone works with one goal. Okay? Okay, I don't know if it's the morning, but I think it's really rough. Let me just summarize it now, okay? Software development is a complex process. It's not a defined process. You're always working on something new. You have a problem that's always changing, that you have no idea. You have a solution that you don't know if it will work, and it's always changing. And you have a set of tools that you don't know if it will work. Think lean product development rather than lean manufacturing. So don't think about manufacturing. This is not predictable and repetitive. Think it's a new product development. It's always something new. The best way to win this game is to acquire knowledge fast. So to acquire knowledge fast, you want empirical data, meaning you actually look and see if you're really hitting your targets as soon as possible. You want that feedback. To have that knowledge fast, you don't separate your teams. You want to have cross-functional teams wherein those who knows about the technology are together with those who knows how to test the technology, with those who knows about the business requirements. Cross-functional teams. With humans, there is no such thing as replaceable cogs. If you have a senior level 3 guy and then another senior level 3 guy, don't expect that they will produce the same type of work. It's not that way. It's a fuzzy way with software development. An agile team is self-organizing and cross-functional, so it should not be a relay race. It should be a rugby team, wherein everyone has one goal in mind, which is to produce business value. And one common about all the different agile practices is that they abide by a set of values and principles. When you make decisions, you think whether am I getting in the way of individuals and interactions with implementing this process, or will our contract get in the way of us actually collaborating? Okay, and then feedback is the breakfast of champions. So it makes, assuming it makes an ass of you and me. Okay. Yeah, I think that's it. So thank you. If you have questions, let me know.